First, we will go through this IP address, classes and types, then subnet and then gateway, route. These are the topics we will be covering. So with respect to networking, computer networking, it is meant for connecting the devices each other. For that purpose, we are using the IP addressing. Okay. So basically, there are two type of IP addressing. IPv4, so it is like IPv4, then we have v6. So it is like v4 was the first started with v4, so it is the 32-bit addressing actually. So this one, the limitation of this IPv4, it is we can address maximum up to only 2 raised to 32 number of devices in the network. So when it is started, the people who developed, they felt that it will be enough, but when started growing the networking, so then the all faced the limitation of the IP addresses. So then started with the v6. So now most of the devices, it is supporting IPv4/v6. So basically today we will be concentrating on v4. So with respect to v6, there will not be much difference whatever the remaining portions, whatever we are covering. Okay. So now, so that is the type of the IP address, two type. Now we will go to the classes. So we can see classes. See total IP addresses. That means that 2 raised to 32. So that is classified into class A, B, then C, D. And E, like that it is classified. Okay, so we can see that class A, it is covering this many addresses. That means see 2 raised to 31 it is covering. So you can see that the starting address and the ending address of this one. So see this is the starting address and this is the ending address in class A. Okay, class B, we can see that it is starting from this ending. That means here we can see that it is ending with 127 dot this. So here class B, it will be starting from here and it will be ending here. So similarly class C, then class D, class E. I think this we already learned. I think this we already learned in our academic and so then we it is not much important with respect to our environment. Okay, so now we will move to the next topic. So that is about the IP address, classes and types. Now whenever we are configuring a network device, that means whenever we are configuring a server or any network device, basically it will be asking 4 things. One is what is the IP address. Next one, it will ask what is the subnet. Next one, it will ask what is the gateway. So next one, it will ask what is the DNS. So now we will see that what are the usage of these 4 items. So first one we already discussed, that is the identification of the node, that is the IP address. Now we will discuss about what is subnet. So subnet, it is like a identifying the network. That means what the local network, how a device identifying the network, it is using the subnet. So I will explain in detail. See, basically it is coming in the routing part. That means see how the packets, it is getting routed. So in that case, the device, whatever device it is communicating each other, it is mandatory to identify that its network for the routing purpose. Okay, so I think before explaining how the subnet it is getting configured and how it is deriving the network addresses, so for that we will just first go through this routes and routing. So routes I will discuss later, routing I will tell you. So first one, assume that there are 2 computers connected into a network. In that, now the first computer wanted to send a packet to the other computer. So first what it will do, it will check that is the destination computer is in the same network or not. So depending on that, it will take two actions. See, suppose if it is in same network, it will say directly route. Okay. Second one, if it is in other network, then it will say give to gateway. So this is the routing method actually. Okay. So first it will identify that the destination IP is coming in the same network or not. Otherwise it will give that to the gateway. So that is the routing functionality. So for this purpose, the device should identify the network actually. Okay. So now how it is directly routing? So there are some method it is following. So that I will explain while coming to the fourth point. Okay. Now we will go to the subnet part. Yeah. Subnet, see, assume that we will take our office IP addressing itself. How we are configured now. See, we are having 10.0.0.0. This is the network. We will say this is the network. And we are telling that the net mask is 255.255.248, sorry. 248.0. So this is the subnet mask now we are using. Okay. Now we'll see in detail. See, basically in an IP address or in the subnet mask, we can see there are 4 octets. Okay. So each octet is having 8 bits. So first we can say this 10 we will convert it as a binary. So it is, this is the binary. So then we have to prefix 8 total remaining zeros we have to pad it. Yeah, this is the first part. Okay. Now second part, all zeros. Then third part, all zeros. Yeah. Then fourth part. This is the network. Now similar way we will put the net mask also. So 255 means all ones. So here, all ones. So here. Yeah. Now 248 means first 1, 2, 3, 4, 5 ones, then remaining zeros. So this is called as sorry, here 1 second, here the third one is 248. Yeah, here this is 248. This is 0. So now the device, whatever computer or mobile, whatever it is, so whenever we are configuring an IP address, so it will see, assume that now we are configuring an IP address 10.0.3.216. So this is the IP we are assume that we are configuring this as the IP for a device. Okay. So whenever we are configuring this and whenever we are telling this is our net mask, what it will do, it will put this net mask on top of this. Okay. So first this is the network. So this also will do for learning purpose, network. This is net mask. So now we will put the, we will convert this IP address also into this format. So here again this is 1010, then remaining 0, one more 0, yeah, then here 0, then 3, yeah, then 216, we'll see that 11011. Yeah, here 1101100. So this is the IP address. Okay. Now what it will do? It will XOR. The operation it is like XOR. So here the operation is XOR. Yeah. So now when we are doing XOR operation, what it will do, wherever this 1 is there, it will replicate the same part here. That means, see this first octet, so it will come here as a 10 only. So I will put the decimal, so just for easy reference. So here whatever it is there, it will come here 0. And this part, see, it will change actually. That means, see the network, see here we can see that, see here 0 0 0 like that actually. So then the network, it is coming it as 0 0. So like that it will get to know the network address. So the first part of this one, it is called as network, and the last, so that means, see here up to see this part here, it can go up to 0 0. That means the first can be 0, then 0 0 1. So like that it can go up to 7. So that means this one means 10.0.0.0. This is called as network address, and this one, the last one, which it is called as, that means 07.0. This is called as broadcast address for this subnet. Okay, I hope everybody understood the concept. That means, see, this is the network, we are giving the subnet mask, we have to convert that into binary. So that means all these 4 octets, it will be converting into binary, and then it will be doing the XOR operation. So then we will be getting the starting address and the ending address and the remaining part of the network IP addresses. Okay, so then the first one, it is considered as network address, last one, it is considered as broadcast address. So this is the how host is identifying that one address is it is in a local address or not. See, assume that now we are giving one IP address 10.0, destination as 5. We will say 27. So we are telling that I wanted to send a packet to this IP address. So whenever the host, the kernel, it is getting this request, it will check that this IP address is coming in my subnet or not. See, here we can see that this 5, it is coming here. So then it will identify this and it will route locally. Okay, how it is routing locally, I will explain later. So this is the concept. Assume that now one packet, it is coming 10.0.8.230. So here we can clearly see that the 8, it is coming here, which it is not part of this net mask. So then what it will do, it will give to the gateway. So then the gateway, it will take the responsibility to route to that network. Okay. So similarly here, see, another set we can consider. See, here we are telling that the network is 10.0.0.0. Instead of that, here we can give the next IP address. That means up to 7, it is in this one. So next here we can say 8 also. So in that case, the starting address will be 10.0.8.0 and it will go up to 10.0.8, 9, 10, 11, 12, 13, 14, up to 14. Like this it will be. So this range of IP address can be there if the network address we are changing to this. Okay, in our office case, we are using starting from 0, 0 to 7 it will be. So this is the concept of net mask. So now we will go to gateway. Yeah. So this is over and this is over. Okay. One more thing is there. See here, representation. So when we can see that when we are configuring the device, it will give you two type of net mask configuration option. Okay, one way we can configure like this. That means we can give a 8 octet, and some of the cases you may be noticing like this. See, we can say network is 10.0.0.0/21. Okay, this is the way also we can represent. This is a simple method. It is like, see, it is counting how many ones are there in this subnet representation. See, you can see that it will be 21. So in case if it is a host, we are telling that, see, if we are telling one IP address 10.0.3.216, we will say 32. 32 means, see, all are 1. That means it is a host IP address. It is not a network IP address. Okay, so that is the way it is representing. So similarly, we can find out that, see, if it is first 2 or 255, it is like 255.255.0.0. You can see here 8, here 8. So total 16. So in that case, it can be like 16/16. So like that it will be representing. So if all 3 are 255, we can say /24. So this is the way also we can 55 it will go. Next it will be 800. So that will be the 80. So that will be the next this one next network starting address. So this will be the network address of next subnet. Okay, yeah, correct. Yeah, now we will go to gateway. So here gateway, we already discussed about the purpose of gateway. That means if any packet which the host needs to send to another network, it will give that packet to the gateway, then the gateway address. So normally the gateway address belong to a layer 3 device. So I will explain that devices also in the coming part. So then layer 3 device, it will be connected between different network and it will take care of the routing part. Okay. So it is like and the gateway, when we are configuring gateway, we have to consider one major thing, main thing. Most of the time we used to face that issue. So for this also I will consider our office building just for representation. See, this is our local network. I will consider it as a local network. So I am showing this as our office. Okay. So here in our office we can see that this is our front road, and this is our which is that this is Richmond Road. Okay, so this is the small road which it is here. So this is our main gate. This is here only our security and main gate, and for 4-wheeler one gate and 2-wheeler one gate. So now this is assume that this is our local network. Okay, now somebody that means if I wanted to go out, so I am considered as the one of the network packet. So I wanted to go out. That means, see, if I wanted to go to our 4th floor, we can directly go here. I wanted to go to ground floor, I can go here. Like that we can locally move around. Okay, so then in that case we don't have to consider the gateway. That means if any packet which it has to send across the local network, then we don't have to consider gateway for routing that packet. Assume that one packet, now it has to go out from the local network, then one of the gateway it has to choose. Okay, so for while configuring, there will be concept of default gateway. Then there will be, we are configuring routes. So that means we can specify that if any packet to a specific destination, if it has to choose a specific gateway, then we can specify those entries in the routes. So that is the purpose of routes. If any packet which it is going out that is not specified in the routes, it will take the default gateway. Okay, so here itself I will tell you, see, concept. So whenever I wanted to take out my 4-wheeler, so then I have to choose this gateway. So that is a specific case. That means it will say that you have to choose this gateway. So then in that case we will specify that the destination. So destination can be a network or it can be a host. So then we have to specify destination. Then we have to specify that which gateway it has to use. and then gateway, when we are specifying, by default it will take the device, that means the network port it will take, and it will take the part. So now here we are telling that see, suppose here itself we will say, now if you want to go to MG Road, you use this. If you want to Richmond Road, you use this. So then here we will say that MG Road is my destination, use gateway 4. Okay, then going to that. So then here we are telling that for Richmond Road, use gateway 2. And we now I wanted to go to Majestic. So now I could not see that entry in the routing table. So what it will do? It will take the main gate. That means that is the default. That is the default. It will take the default route and it will go there. So here the main thing, see, whenever we are configuring the gateway, that gateway address should be in our local IP address range. See now, see, assume that now here there is a building and there is a gate here. This is a different local LAN. I cannot configure that my gateway is this because I don't have entry to that gate. Correct now? So this concept you just keep it in mind, so then we will not make any mistake there. That means whenever we wanted to configure a gateway, either for a specific route, this case, or for a default gateway case, that gateway IP address should be part of our local network address. Okay, so this is the concept of gateway. Hope this one also is clear now. Gateway will be considered only in case when any packet needs to go outside of the network, local network. Yeah, now that is over. It is opening itself, it is taking time. Yeah. Now we'll go to the routing, routes and routing. So routes we have already explained. That means that is the specific routes. Other than the gateway, we will be using the routes for going out the packet to a specific network. Okay. So now routing. So routing, I told there are two type of routing. Oh, okay. I think my whiteboard is crashed. Yeah. For routing, there are basically two types. One is actually local routing. That means local address. Then routing to a different network. First we will consider how it is locally routing. So you may be heard about a word like ARP. Okay, ARP, it is like address resolution protocol. Assume that now here is a host which it is IP address is 10.0.3.216. It has to send a packet to 10.0.3.217. First, it will identify that this destination, it is coming into local network. So by using that net mask, it will identify that it is coming in the local network or not. So then it is identified that it is local network. Then what it will do, this host, the kernel, it will send a ARP request. For this ARP, it will be using broadcast address as a common this character. So our broadcast address will be 7.255. So it will be using this address and it will broadcast this ARP request. So ARP request, it is like it's a simple word. It is like who is having the IP address. IP address 21, this one 10.0.3.217. Okay. So then what it will do, it will broadcast to all the devices which it is connected to this local network. So then the node, the host which it is having this IP address will respond back saying that yes, I am having this IP address. then this is my MAC address. So I think most of us will be knowing that what is the MAC address. MAC address is the hardware address of the connected network device. So this will be a unique address. So that address will be shared to the origination host. That means this host will receive a response back from this MAC address. It will say that see, I am having this, I am holding this IP address 217 and my MAC address is this, like that. It will give you one MAC address. So then what it will do, it will forward that packet to this MAC address. So after this ARP, so first one ARP, so then response, then it will forward that packet to the MAC address. The MAC address. Now there is a concept. That means, see, there are different layers of devices. Basically earlier there are devices like hub. So now it is no more using in any network. So then there are switches. So here this is actually layer 1 device and this is layer 2 device. So I will explain why it is called as layer 1, layer 2 and so concept wise, see now what it will do, these both are connected to the switch. So we are telling that 216 and 217 it is connected to switch. It can across the switch also. That means, see, there are another switch here and it is connected together. So that also can be possible. That means this can be connected to this switch also. So in that case also this broadcast will happen. So then whenever the request it is coming, it will broadcast that message internally this switch to all the ports, whatever devices connected, it will broadcast here. Okay, so whenever the destination node, it is telling that this is my MAC address and I am holding this IP, the switch also will understand that, see, one port which it is connected, see this one, it is telling that, see, this is having this MAC address, MAC 1. So it will record that information in this one table. That means port 7, this is MAC address. Like that, port wise it will map the MAC address and it will keep that information. So then from next packet onwards, when it is sending this MAC address, so then directly this switch will be knowing that, oh, okay, the port 7 it is having this MAC address, so then it will send to only this destination. But the hub case, this table entry is not there in the hub. So then what it will do, all the packet it will route across all the ports. So that's why nowadays hub it is not using, because the network traffic will be more and there are some concept of collision, all these things are there. Okay. And see, one more concept I will tell you why we are restricting to a smaller network. See, depending on the number of hosts we wanted to connect, so depending on that only we will be using the net mask. Assume that, see, now we are using 255, then 00. In that case, you can see the broadcast address range, it will be very huge. That means periodically there will be several broadcasts, the network traffic will be more. So that is the way it is reduced. Okay. So I am not covering, there is a virtual LAN concept, VLAN, so that is not considered here. So that we will see later. Yeah. Now gateway covered and routes and routing. So that also covered. Now DNS. So DNS, it is like, see now whenever we are entering the domain name in the browser, we will say that https then google.com. We will say this. So here there is no IP address. Okay. So basically the kernel, the operating system kernel can use only IP address. Okay. After that IP address, it will try to get to the MAC address. So basically the actual packet, it is flowing on with the MAC address. Okay. So then to identify the IP address of this, so for here it is called as a domain name. This is the domain name. So to resolve this domain name to an IP address, we need a domain name server. So this is DNS. So what it will do, whenever browser is using this domain name, internally what it will do, the operating system will take that domain name and it will send a request to the DNS server asking that what is the IP of this domain. So then what it will say, google.com is the domain name, enter. So then DNS, it will give you one IP or multiple IPs for that domain name. So it will return that 117 these IPs. Then with this it will be routing the packets. So that is the usage of domain, this one DNS entry. So now we have covered whatever we are entering for a network: IP address, subnet, gateway and DNS. So these are the entries basically when we are configuring a network, it will be asking. Okay, so now we will go to the network devices. So network devices, there are 4 type of devices. Yeah, so these are the devices we are using in the network. So here we already discussed about the hub, and then NIC is the network interface card, then cable, if it is Wi-Fi, then wireless. So these are called as layer 1 devices. That means we know that, all of us know that there are 7 network layers. So in that, the first layer is the physical layer. So all these devices are operating in that layer. Okay, so layer 2, it is the data link layer. So data link layer, see, our whatever we discussed, the switch, it is coming into layer 2 device. That means it will be able to identify the IP address in that the packet. So now layer 3 is the network layer. In that, the router, it is coming. So a router only is configuring as a gateway. That means, see, now assume that here there is a local network 1 and here is a local network 2. So then this router will be connecting to this both of the network. So here we will configure this this interface, it will configure as gateway 1, and this interface it will configure as gateway 2. So then in whatever device is coming under this local network, it will configure this gateway 1 as the gateway for the packets. So then if any packet needs to go to this network 2, it will come to this interface, then router will get that packet, all the routes configured in this router to send that packet to the network 2. So that packet, it will go here. Like this, the routing will be happening. That is in the layer 3. And here we can see next one is the transport layer, layer 4. So the firewall will be coming in that category. So firewall will be having a capability, routing also it will take care. Apart from that, we can configure some rules. We can say that allow this destination, don't allow, or block, all this configuration, and even tunneling or port forwarding, all this type of functionality is included in the firewall. So these are the network devices basically using in a computer network. So that network device is over. Now ports and sockets. Okay, so basically ports in our application also we will be knowing that we will be using different ports. So assume that this is a computer. So this is a computer 1, and here there is a computer 2. Now there is a concept of server and client. That means if you want to send a packet to this computer, and there should be some application will be running to receive that packet and process it. Actually, for receiving, there will be, see, the network cards, it will be receiving it. But after that, in the 7 layers, so after this it has to go to an application layer. In that application layer, there will be some server will be running, and it will be receiving and responding. Okay, for that actually we will say this server will be running a port, we will say that 8080 is the port, we will say this is the port. So whenever we are starting a server, here it will open that port. It will say this is the listening port. It will say 8080 is listening port. Listening on this port. Okay. Now whenever a client, when it is sending a packet, it will mention that this is meant for port 8080. So that packet will come here. The kernel will giving to this. So that is called as port. Okay. So now assume that there is one more client, it is C2, it is there. Okay. Now that also is sending a packet to same port. So how it will get identified? Is it is from C2 or is it is from C1? So for that actually internally when the communication happens, there will be a socket created. That means here there will be a socket created, that is called as socket 1. Here there will be a socket created, that will be a socket 2. So then there will be a socket ID will be given, that is a unique ID. That means S1 will be an socket ID of one, I think it is a 16 digit or something like that, one long number. So similarly there will be a socket ID for the second socket. So like that multiple sockets will be creating depending on the number of clients and the communication will be happening. So that is about the port. Okay. Yeah. Now that is the ports and sockets. So basically the sockets considered it as a IP with a port. Port means only is a number 1 to I am not sure exactly how much it is supporting in the Linux, and there is some restriction like the root user only is allowed to use the lower number ports. I think 80 NLR will be allowed only by a root user and others can use the higher range. So whenever it is coming with the IP port, then it is considered as sockets. Okay. And now we will see that the reachability of the IP. Okay, that means see now we configured the IP, we configured to host everything. Now how we will get to know that the destination node it is reachable or not? Okay, for that purpose we can use the Telnet or there will be clients. Network client, so then we can connect to the server. So there will be a ping. So that means ping, what it will do, it will send the packet, ping packet to the destination, as in that we will be sending. So see, this is the way it will be sending the ICMP packet. So that is meant for the ping. That means it will just send the packet, it will wait for the response and see that how much time it is taking for that round trip time. So how much time it is taking to reach there and come back. So this is the way we can see the reachability. But if it is across network, this ping most of the time it will be restricted in the routers. So in that case there will be a command to know that traceroute. So as in that we have to see google.com. So we will be getting this IP address. We can see the traceroute. See, we can see that where until it is going. So first it is going to our office firewall. So that is our 10.0.3.1. After that it will be going to different routers. So these are the router addresses. So finally it will be reaching to the destination. So that is the way we can check the routes. Now next one is actually how to test the ports. That means we wanted to see the reachability of the port. So first we can see, we have to see that the port it is listening or not. So there is a utility like NC, the netcat utility is there. With this we can open a port. See this command it will open in a IPv4 1234 port it will be opening. Okay, so if you just open one another terminal, and if you are checking that, we can see it is listening or not. See, we can see that it is listening on that port. Now from this server we identified that it is listening. So from another server, if we don't have access to that server, so then how to know that it is listening? So then the telnet command we can use it. We can use the telnet command, then we can give that IP address, then we can give the port address. See here, if it is getting this response, we can see that it is connected to that port and it is waiting for the remaining information from the socket. So this is the way we can check the port reachability. Now the last point which we are planning to cover in this session, it is virtual IP. So virtual IP, it is basically assume that there are multiple hosts meant for serving a specific request. That means we can say we are having an application, assume that there are 3 or 4 nodes or minimum 2 nodes. Which it is meant for giving the GUI, or we can say giving for API. The API server is running in both the nodes. So in that case, see the example I will tell you is now google.com. So google.com, you can see that it is only a one domain name, but basically in the backend there will be several servers will be ready to serve that single domain. That means from the entire world there will be lot of requests coming to that domain. So then it cannot be handled in a single place. Okay, so there will be a load balancer. So then it will be distributing that across the nodes. So in that case, basically there are different methods we can use that. There is a load balancer application will be there that can manage the load, or we can say in our small installation case only 1 or 2 servers are there. So in that case we can go with the virtual IP. So virtual IP, it is like, see, physically that nodes will be having physical IPs. Apart from that, we will be configuring a virtual IP. So the virtual IP concept, it is like it can sit on any of the available node depending on the availability. So this is basically we are using for high available case, and that means, see, we are having 2 API nodes. So then if first the IP will be there in one node, so depending on the configuration, so we can say if this node is not available, shift that IP to the second node. So when this node is coming back, shift back or keep it in the second node itself. So like that we can configure. So that is the purpose of virtual IP. So earlier we were using the different what we can say different softwares to supporting that virtual IP. So basically now we are using the one which it is keep alive, that is bundled with our operating system. So keep alive, it is internally using this VRRP protocol. So VRRP here we can say it is a virtual router routing protocol. So basically this one was developed for the redundancy of the routers in the network. That means see, assume that there is a network 1 and there is a network 2, and there should be a router in between to route the traffic between these two. Assume that if this router is down, then we cannot reach this network from N1 to N2. In that case, we should have a redundant router. So here router 1 will be there, router 2 will be there. So like that it will be. So here it will be linked together. That means these two will be in a local LAN actually. So then what it will happen? Whenever this router is down, it will take this path and it will go. For that purpose, this protocol it is developed. Actually, see the how it is working, I will tell you. See, assume that the virtual IP we are configuring as this is network 1, network 2, and the router IP we are telling that 10.0.3.2 is the router IP. Okay, this IP we will configure it as a virtual IP across both the routers, and then both the routers we will give a weightage. We will say that priority for router 1 it will say 100, and priority for router 2 it is 150. Okay, so then whenever both the routers are up, both the routers will be sending a multicast message. So that's why here I put the type of broadcast and multicast. What is the difference, that I will explain. So here it will send a multicast address saying that I am alive. That means it will send that my priority is 100. Router 2 will send that my priority is 150. I am handling this IP. I am configured to use this IP. So depending on this, both the routers will be getting these messages. So then whoever is not getting that higher priority than that self configured this one, so then that will declare as I am holding that IP. Suppose that, see here, priority, this is lower priority, this is higher priority, and this is lower priority. When this is sending a message to here, it will be knowing that okay, higher one it is active, so then it will keep quiet. So whenever it is not getting this message, this multicast message, it will be immediately identifying that oh yes, the higher one it is not there, so then I have to take that responsibility. So then what it will do, it will configure that virtual IP under this. So like that the virtual IP will be keep shifting that. So the one thing we have to take care, actually, see, this IP it will not be listing by ifconfig command. Ifconfig, if you do this VRRP IP will not be listing. So for that we have to use IP. Command is IP-4 address. This command we have to use that. So then we will be able to see that who is holding, which server is holding this virtual IP. Okay. So now there is a concept of broadcast and multicast. So broadcast we already discussed with respect to this routing case. That means if any packet which it is needs to be sent to the local network, the device will be doing a broadcast. So then the packet will be sending to all the network nodes. Multicast, it is like the small part of a broadcast. That means it is not sending to all the node. It will be sending only the multicast domains. So then in the Linux controller we can configure that the configured IP is a multicast IP or not. So in this case what it will do, whenever we are configuring this router, the IP address what it is physically holding, it will automatically internally it will configure as a multicast. That means, see, if router 1 and router 2 is there, that packet, this health check packet will be flowing only between that two routers. It will not be going to all network nodes. So this will help to reduce our network load. So that is about the multicast and broadcast. Actually, I am covered all the topics whatever I am listed. So then you can give your feedback, and if need we will